Grand Project Gravity Assisted Pulse Motor Update. We have the commercially bought PMA permanent magnet alternator with a built-in bridge rectifier installed. It's just going to a cap. Just doing a one-to-one gear configuration off of the transmission, and there's no binding, but there is some cogging with this PMA, and it immediately comes to a stop. So there's no I don't know. It doesn't move as freely as the home-built version, I guess is what I'm trying to say. So we'll power it up and see what kind of results. So this is with a manual assist. We can get it up to about 30 volts output. This is with a manual operation, and so this will give us some idea of the RPM required to get a cut-in voltage. And the next step will be to replace the falling weight with the dual pendulums and dual lever arm. So we have most of it fabricated. It'll just be a matter of fabrication, and then we'll be able to do more testing. But at this point, it's safe to hook up the output to this and see what sort of readings we get under manual. Okay, so let's see here. We have the MPPT controller hooked up. The machine is not operating. There's not enough force generated by this by the falling weight to actually operate the commercial PMA. So I've been manually operating it just simply by lifting the weight and applying a small downward force to see what sort of outputs we get. Right now, okay, the auxiliary has kicked on, so it doesn't overcharge the battery. There's not enough force produced with the falling weight to actually operate this permanent magnet alternator. What I've been doing is lifting the lever arm and then applying a small force to generate a voltage. And let's see, right now oh, there we go. So under manual operation, it's putting about a 4 amp charge into the battery. This just gives me some idea of the input force that's going to be required if I use this PMA. The next step is to fabricate a buck converter that'll handle the VOC value of the homemade permanent magnet alternator. And this was just a quick test to see if I could find some off-the-shelf products that would work in this situation. And it looks like we're going to have to fabricate our own to get better results. But so at this point, yeah. Okay, so when it stops, and then when it goes or starts we're getting about 4 amps from this output. The batteries on the I don't know, flashing lights mean something, but not exactly sure. But it's protecting. This device is acting as a battery charge controller because the auxiliary light is on, so it won't damage the battery. the controller is doing some peculiar things. It's still somehow it's still either that or I got a bad meter, but it's still inputting 4 amps into the battery, unless there's a problem with no, see. Huh. Yeah. So this controller's doing some peculiar things. Seems to be working. It hasn't blown up, which is a good thing. But we'll have to design our own circuit, or complete fabrication of our own circuit, and we should be getting better results. But it gives you some sort of idea of the force required to operate the commercial PMA. Yeah, it quickly comes to a stop. So we're heading in the right direction. Need more force on the input, which will come from the dual pendulum configuration, and we'll be replacing this with a buck converter that we've previously designed in the past. So we're working on version 2 now, and then make some new stators with some heavier wire for the homemade PMA. And it'll be a couple of weeks before we start testing again. But thanks for watching. Enjoy the day. Cheers.